How are you, my friends? Let's continue Algebra Course Lectures. Now we reach lecture number 13. Just to mention that lectures 13, 14, and 15, they will cover rational expressions. So they are almost the same topic and they are related. Now we start with lecture 13. In this lecture, we simplify rational expressions after we define what is a rational expressions, and we will also multiply and divide them. Just to mention here, lecture 14, you can expect that addition and subtraction. So the objectives of this lecture is to find the domain of an algebraic expression, to simplify rational expression, and multiply and divide rational expressions. What is a rational expression? A rational expression is an expression of the form P over Q. P is a polynomial, Q is another polynomial, and then we have to simplify them. Remember, we have seen before, maybe lecture number 2, rational numbers like 2 over 3, 5 over 7, 6 over 5. Now, these are rational expressions, same idea almost everywhere, except little difficult and simple conditions here because we have x, y, k, w, m, we have some variables and letters. So the aim of these lectures is to simplify them. So we will have these expressions here, rational. We need to simplify them. For sure, the main idea here is to use factoring. Now let's look at the domain. Let's define it first. Domain is one of the important concepts in math. It is the set of all real numbers except the values of x where the expression is undefined. When we say expression is undefined, it means the denominator is 0. Let's take two simple examples here, then I will say the definition again. 2x plus 77 divided by x minus 9. That's an expression, rational expression. I can replace here any x I need except some values. So I can put x equals 0, I can put x equals 3, x equals 1, x equal 100, x equal minus 17. Now, if I put only x equals 9 up and down, see, I will have here 0 in the denominator. So that means the number that will make the denominator 0, which is 9, should be excluded, taken out. It is outside the domain. So the domain is all the values of the x that will make the whole expression defined. So r minus 9, or we say all real numbers in English except 9. Let's see another example here. X plus 6 over x squared minus 4. Now we care about the denominator here. If we factor this denominator, x minus 2, x plus 2, difference between two squares, we can see clearly what will make the denominator 0, which is 2 and minus 2. So these two numbers should be outside the domain, because domain, again, is the values of the x that we can replace or substitute in the expression. We cannot substitute x equals 2. We cannot substitute x equals minus 2. So we say the domain is R except 2 and minus 2. Two values should not be in the domain. Now let's find the domain of these rational expressions. The first one is easy, I think. The second one is not easy. Let's see. If you factor this x, m minus 3, m plus 3, you can cancel m minus 3, but still it should be counted in the domain. So what will make the denominator 0 here? 3 and minus 3, right? Okay, good. Now here, try to think before you see the solution. Number B, example 1B, 2x over x squared plus 1. What will make the denominator 0? So the domain R accept what? Let's see, in the first one, if you factor m minus 3, m plus 3, even if you can cancel m minus 3, still the domain is R except minus 3 and 3. You can put 3 or minus 3. Now in this one, see there is a plus here. Sum of two squares we have seen in the factoring. We cannot factor this x squared over real numbers. So the domain is R, or minus infinity to plus infinity. Or R except nothing. No number, look here in English, no value for x. Try any number you like. No value, no real number of x will make the denominator 0. Okay, good. Now this is try at home. You know, try at home, extra questions, practice, all these complete solutions you can find, only I put the answers here in the lectures. You can find them in another videos where we have additional solved questions. Now let's start to simplify. We have here the fundamental principle of fractions, a times c. Just remember that, so easy. Divided by b times c, you can cancel the c, and then it's a over b. Remember, b cannot be 0, c cannot be 0, because they are in the denominator. Now, if we have an addition here, you cannot cancel. This is the fundamental principle only if we have a times c. Let's look at simple example before we start other examples. D squared minus 2d minus 15, 2d squared minus 10d. I have seen students canceling d squared because you see it's up and down. Completely wrong. Completely wrong. You cannot cancel. Why? We have a minus, minus, or pluses. So what do? Factoring. See the idea, the theme, the main idea in this lecture and other lecture 13, 14, 15 is the factoring. So d squared minus 2d minus 15, we have seen lectures in factoring. Lecture 10, 11, and 12. You can review them if you like. So this is a trinomial. D plus 3, D minus 5. Okay, you can just review them. It's easy. Find two numbers, their sum is minus 2, their product is minus 15. This one is a common factor, 2D, D minus 5. Now we can cancel D minus 5. Now D minus 5 here is like C. You cancel, you see? You see there is a C here, cancel the C. Then we have A over B, D plus 3 over 2D. That's the final answer. We cannot cancel the D here. We cannot because of the plus or the minus. I hope it's clear. Let's go. Example, 2 parts. You can pause the video a little, please, and then you can try them. M squared plus 2m minus 8 divided by 2m squared minus m minus 6. This is another simple, easy, important number 2 actually. Let's make this in lowest terms. Sometimes we say lowest terms, simplest terms. This one we can factor, and this one we can factor. See, you cannot do these lectures 13, 14, 15 unless you are expert in factoring. Okay, let's see, number, both together. Okay, good. So the first one, we trinomial here, m squared plus 2m minus 8, because the leading coefficient here is 1, so we factor m minus 2, m plus 4. Two numbers, their sum 2 and their product is minus 8. Now this and the leading coefficient is not 1. You have to go and see lecture number 11, slide and divide, we call the method. Or there's another method, fast, you just try here, we call it trial and error. 2m times m is 2m squared, that's minus 4, yeah, it's correct. Now we can cancel m minus 2. This is the final answer, m plus 4 over 2m plus 3. We cannot do anything there. Now, this one is a little tricky. X minus y divided by y minus x. Many times you can see this in many exams, many books, examples, etc. When you see a minus between the numbers, like a minus b, b minus a, x minus y, y minus x, this form, m minus n, n minus m. Leave 1. See, let's leave the denominator, leave it. And here I will write minus y at the beginning. This is only to explain the idea. Minus y plus x. Take a minus common factor. If you take a minus from here, you will get y minus x over y minus x. Then I can cancel the y minus x. Altogether, it's minus 1. So always when you see two numbers subtracted in different ways, and you divide them, you get minus 1, always. If you have a minus b over b minus a, directly you can go to minus 1. This is the explanation here. Now, let's just try at home also. You can try these. And the answer is there, you see. Do some factoring. And then the answer, you can see additional solved questions. There's a playlist called additional solved questions. You can find the solution complete. Now, let's multiply. Multiply rational expressions. We multiply rational expressions as we multiply rational numbers, numerator by numerator. So P over Q here, P over Q times R over S. Multiply the numerator, PR, divided by QS. Now, this is the rule, but we don't have to multiply actually the numbers. Like look at this example here. 10xy cubed, 3x power 5, 12x squared times, because it's times 5. I don't have to multiply 10 times 3. I write here 30. 12 times 5, I write 60. I don't have to multiply the numbers. Because if I multiply the numbers, then I have to simplify them again. So one smart thing you can do here, you can learn this idea. Very smart idea. You can write the numbers here. You see, you can write them. Try to cancel. Divide by 3, divide by 3. So that's 4 here. 10. Divide by 5, divide by 5. There is a 2. Divide by 2, and there is a 4 here. Divide by 2. So you have 2. Now the variables, you can subtract the power. Because division in the power exponent, 6 minus 2, that's 4. And y cubed, 3 minus 2 is y, power 1. So the final answer, x4, y, divided by 2. I don't have to multiply big numbers. Even if you have any numbers there, try to simplify before you multiply. That's a big hint. Let's see. Here we have a rational expression, another rational expression. Can we cancel m squared? Never. Can we cancel here 3m? Never. What do we have to do? I can hear you. The main idea is factoring. Let's go and factor each one. See, in the first one, there is a common factor. So that's 2 terms. 2 terms, you go to lecture number 10. 3 terms, 3 terms, 3 terms. That's lecture number 11. 4 terms or more, you go to lecture number 12. Easy. Oh, it looks easy. The first one is a common factor. This one, m minus 4, m minus 1. And this one, m plus 1, m minus 4, because the sum here in the middle. If the leading coefficient is 1, this is the sum, this is the product. M plus 3, m minus 1. You have to be careful which one to cancel. You have to cancel up and down if you have multiplication only. So you cancel this, m minus 1. See the colors? They will go together. This is the same color here. This is the same color. So what's left now? M over m plus 1. Can we cancel the m? No way. All right. Now dividing. Okay. Remember this. A over b. Remember this one for numbers. We can use it also for rational expressions. A over b divided by c over d. A over b times the reciprocal here. So the first one times the reciprocal. Now, p over q divided by r over s. I leave p over q, change division into multiplication, reciprocal of this, s over r. So this will be ps over qr. This is easy example. Then we see other examples on the next slide. So 2k all squared, you see, all squared. 2p all cubed divided by 6k cubed divided by 16 p squared. So simple to figure it out. The first one, we distribute the power here, 4k squared, and this one 8p cubed. Remember, division becomes multiplication. Reciprocal here, you have to flip it, 16p squared over 6k cubed. Just simplify the numbers. As I told you, do not multiply 4 times 16. Do not multiply 8 times 6. Try to cancel. See, cancel here 4, cancel here 4, that's 2. Cancel 2 and 2, that's 8. And then cancel another 2. It will be 4. And then decays will be 1k down, 1p down, because 2 minus 3 is minus 1. So 4 over 3kp. You can figure it out. You can write it down on a piece of paper, and you have to do it easily. Or you can try, oh boy, look at this nice question. Nice question, wow. We have a rational expression divided by another rational expression times another rational expressions, different powers, cubes, squared, different kind of factoring. For sure, the main idea you know now, the main idea here is to, number one, you have to factor everything. Number two, change this one here. You see that? Division. Now multiplication is easy, leave it. This one you have to convert. So this one times the reciprocal of this, times that. I advise you in such a question here, just pause the video for a little, try to self and see if you can reach the correct answer in the next slide or the slide after that. Okay, ready? Let's go. Ready. Okay. Did you get x squared over 5x minus 1? This is the answer. Did you get that, the answer? Or maybe you will get minus x squared over 1 minus 5x. See, I started with the answer. These two are the same. See, because this is a minus in the numerator. In mathematics, we can take this minus and put it down. So it becomes x squared. If you multiply the denominator by minus, you will get 5x minus 1. This is correct answer. This is also correct answer. Or another way you can see it, if you have this answer here, this one, you can multiply up by minus 1, multiply down by minus 1. You get the same answer. Let's go and see here. The first fraction we leave, see 5 here, take it a common factor, x squared minus 4. This is a trinomial. We see trinomial means 3 terms, x plus 3x minus 2. Changes division into multiplication and take the reciprocal. So the minus 2x becomes in the numerator and this one in the denominator. Leave this one here. Oh, take a common here. X cubed, 6x squared, 9x, take a common. After we take a common, we see this is a perfect. See, sometimes we have one question, all the rules together. X squared, 6x plus 9, that's squared, all squared, perfect. Now, let's go here. X squared minus 4 is x minus 2x plus 2, difference between two squares. And this is a trinomial, x plus 2, x plus 3. 10 here, see there is a 10 here, take 10 out, 1 minus 5x. Now, the colors, look at the colors. Oh boy, I put so many colors in the cancellation. You see this blue, there's a little trick here. See x plus 3 squared, if you cancel all this, see when you cancel, you put the line in the middle, but I put it aside so that you can see, okay? You can put it in the middle, but I will not hide. Okay, so this one is the blue, see the squared. So there is a blue and blue here. So that's x plus 3 squared. Okay, that's the green x minus 2, x minus 2. The purple x plus 2, x plus 2. The 2 here, you see, this 2 with the 2 becomes 5. And then 5 with this 5, it will go. So what's left? X, this x and this x, so they're not cancelled, this x squared with the minus divided by 1 minus 5x, then I explained the answer here. One of these will be the answer. Now, another nice questions to try at home. This is something divided by something times something, something multiplied by something divided by something. Both are nice, really. Second one is best. So the answer, I think the answer on the next slide, yes, the answer is the next slide. If you want to see the complete solution of this, directly you can go to additional solve questions, simplify rational expressions. These are the answers. Now this topic, it is to be continued in lecture 14. Thank you very much for watching. If you like this video, you can subscribe, share with other videos with other friends. And then this is lecture 13, just to remind you. Thank you very much.